Good afternoon, ladies and gentlemen. I am from the industry right now, and I am going to speak on advanced material for defense and aerospace industries. Initially, I will brief about our company. Then, on the initially I will give a briefing about our company. Then, the importance of rare earths in our day-to-day lives. The slideshow is not working.
So it is. So you just press this for whichever slide. The slide will be shown on the screen.
Indian Rare Earths, now IRL India Limited, was constituted in the year 1950 and was one of the first PSUs in the country. It was the vision of the Dr. Homi Jehangir Bhabha, and when he established the first setup, he said profit earning was only secondary as against the greater role IRL had to play. Way back in the year 1950, he had understood the importance of rare earths. Now, this is the Atomic Energy Program and IRL's position. We are mandated by the Atomic Energy Act 1962. The AMD is our sister concern which carries out exploration, and then mining, processing and refining. The entire ambit of exploitation is carried out by IRL India Limited. Then after refining, some of the strategic materials are given to NFC, which in turn they convert to zirc alloy, and which is used in the atomic nuclear power program of our country. Then the strategic minerals are given to BARC for strategic applications. Now, this is the reason why the entire ambit of mineral sand processing is under the ambit of DAE. As you see, as we go from the BSM ore and gradually refine the material, the radioactivity level increases. So, that is kept under the ambit of DAE, and if you see the mineral processing plant, after the mineral processing, we produce 5 minerals which are free from radioactivity and are given to the customers. Then there is a RE mineral upgradation plant. Then it goes to the RE extraction plant where RE is rare earths are extracted along with strategic compounds. Then it goes for refining, where we produce around 6 rare earths which are there in our sources. This is the overview of IRL. The corporate office is in Mumbai. Our mining and mineral separation plants are located in Chavra, Kerala, Orissa, Ganjam district of Orissa, and in Manavalakurchi district of Tamil Nadu. The corporate research center is in Kollam, Kerala. Now we have a RE refining plant in Kerala and RE extraction plant in Ganjam. Now the green highlights the new projects which we have undertaken to increase the RE bearing minerals. That is Brahmagiri project in Odisha, a joint venture of IRL, and the Middalam Inayam project in Tamil Nadu. We have initially, very recently set up a RE and titanium theme park in MP and RE permanent magnet plant in Andhra Pradesh. Now, if we see what are rare earths, it is a group of 17 chemical elements vital to manufacture of high-tech products. Scandium and yttrium tend to occur in the same ore deposits as lanthanides and exhibit similar chemical properties. So they are also called as rare earths. The light rare earths are lanthanum to samarium, and heavy rare earths are gadolinium to lutetium. Now, if you see the rare earths out there, I have circled some of the rare earths in red. Those are the ones which are available in Indian resources. Now, this is a brief about IRL operations at a glance. We have 2 types of deposits. One is the dual deposit, the other is a placer deposit. So we mine them using manual mining methods mechanized mining as well as excavators. Then the mined out sand is pre-concentrated, and then mineral processing carries out where all the 7 minerals are, we produce all the 7 minerals. Then it goes to, then the RE bearing mineral goes to the rare earth extraction plant, and after extraction of rare earths, the RE concentrate is sent to the RE refining plant for production of refined RE, that is separated high pure rare earths. Now lanthanum, cerium, neodymium, praseodymium, samarium, gadolinium and dysprosium, those are available in Indian resources. Now if you see the global mapping of RE deposits, the Mount Pass deposit in US has about 8.24% REO, but they still do not carry out any refining or extraction activities out there. The biggest producer, China, has a deposit of 6% REO. And the deposit, in addition, contains iron oxide, copper and gold, making the extraction extremely viable. But in India, we operate at around 0.056 to 0.058% REO in our source, which is 100 times leaner compared to that of China. If you look at the world demand, light rare earths demand is around 1,26,000. In India, it is hardly anything, only 300 tons. And heavy rare earths demand globally is around 5,400 tons. In India, it is minuscule, a few grams. And this is IRL's rare earth portfolio, plus 96 RE bearing mineral is first produced. That goes to the RE extraction plant. Then individual rare earths are produced. Samarium oxide is produced by IRL. Then that is converted to samarium cobalt alloy based on BRC technology. Then based on technology given by DMRL, it is converted to samarium cobalt magnet. The plant has been set up at BRC complex, Vizag, under the aegis of DAE. Now, coming to heavies, we produce gadolinium and dysprosium, but its content is to the tune of only 1 ppm and 7 ppm in the earth crust. So, we have mastered the technology to extract elements available in ppm form. Now, some of the initiatives of IRA in the field of RE is through Automotive Research Association of India, we have developed a 3-way catalytic converter. It is presently under field trial at Mahindra & Mahindra and Varroc Engineering. Then, through our in-house R&D, yttrium stabilized zirconia, containing 8% by wet yttrium oxide in zirconium oxide and lanthanum zirconate. A bilayer coating was applied on Sukhoi 30 engine nozzle by HAL. It withstood complete long-term endurance testing and 100 hours in a test bed of equivalent flying. Similarly, lanthanum zirconate was tested at IGCAR Kalpakam by applying coating on high-density graphite. It withstood 5 thermal cycles at 1500 degrees centigrade. Generally, it withstands two cycles. Our material withstood 5 thermal cycles. So thermal barrier application materials of various grades IRE is able to manufacture. Now, as you may be aware, rare earths free from radioactivity is open to all the private players, but till date, nobody has shown interest in setting up any downstream industries on rare earths. So taking that initiative in order to encourage entrepreneurs, IRE with the help of BRC has set up pilot plant facilities for production of metals of lanthanum, cerium, NdPr, then plant for extraction of rare earths from e-waste, and for production of LED and lamp phospho. These were developed by BRC in gram scale. We have scaled it up to about 10 kg scale each, so that entrepreneurs can come, have hands-on experience in these facilities and develop commercial operations. Now, this is the rare earth permanent magnet plant which was inaugurated by Honorable Prime Minister on the 25th anniversary of the World Technology Day on 11th of May. Now, this plant will be producing samarium cobalt magnets for use by defense, space and atomic energy. The commissioning of the plant is in progress and the first type of magnets have already been produced, which you can see in the last picture out there. Now, if you see the global RE ecosystem, people say that India is not doing anything in rare earths. But if you see, India is there in mining, India is there in extraction, in refining, and in refining, India is among 4 countries in globally to carry out RE refining. India is also there in production of lanthanum and cerium metals, though in pilot scale, and production of RE magnets also. There are only 4 countries globally producing metals and magnets. Then the end-use applications, as Sir said, is not available within the country. Then catalyst, phosphors, polishing. These industries are not existing within our country. Now, these are broad applications of rare earths. They find use in phosphors and glass, catalyst, electronics, permanent magnets, nuclear energy for e-mobility, high technology devices, and for with this upcoming ESG norms, strict ESG norms, we have to turn to green energy. And for green energy, the driver rare earths are the magnetic rare earths, which are neodymium, dysprosium, praseodymium, samarium. They are used in EVs, in wind turbines, in e-buses. You name what, they find the application. But they are used in very meager quantities. These are some other applications of rare earths. And these are the defense applications of rare earths. In Tomahawk cruise missiles, smart bombs, NdPr, samarium, dysprosium, and terbium are used for making compact and powerful magnets for guidance and control and electronic motors and actuators. Similarly, for nickel hydride battery, aerial denial system, jamming devices, lot number of rare earths are used. Then for targeting weapons, again, yttrium, europium, terbium are used. Then for hub-mounted electric traction drive, integrated starter generators, etc., electric drive systems, again, NdPr, samarium, dysprosium, and terbium find use. These are some other examples of rare earth in defense. Then I want to just talk about one of our other products, which is a titanium-bearing mineral. That also finds application in defense in a large way. And zircon also finds application in nuclear applications, basically to make cladding tubes to house the nuclear fuels. And these are some of our other products like sillimanite and garnet, which are used in ship blasting and cleaning. Now, what are the challenges in RE sector? First of all is the high environment cost. Second is limited technical expertise on mining, cracking, and separating outside of China. We have to handle large volume of hazardous process residue. Economy of scale, low consumption of RE products within the country, hence we are not able to scale it up. Long gestation period for project setup. It takes minimum 10 years to set up a RE processing facility. Developing a rare earth mine and processing plant, it is highly capital intensive. And most deposits contain radioactive material that must be contained and stored. Otherwise, it will spread radioactivity. That is all from my end. Thank you.